All right, getting ready to go. Awesome. Hello, hello, hello. How are we doing today, everybody? Good. Glad to hear it. That me too. I am also good. Fantastic. So today, I'm thrilled to be here with you today. So in this session we call You Can Code. My name is Christian Hubicki, and I'm here to teach you how to code in Python. And for anyone joining us today here in the room, we have middle school students, high school students, and anyone who's joining at the YouTube link, welcome, welcome, welcome. Um, so a little bit on who I am, friends. I am an associate professor of mechanical engineering. Yeah, I'm a professor at a college, particularly Florida State University. That's in Tallahassee, okay? And I work at the College of Engineering. I'm a mechanical engineering professor, okay? And mechanical engineering encompasses so many different types of fields. Sometimes about like materials, like how you make materials, a little bit of material science sometimes. It could be about like fluids and heat and flying devices. What I focus on are a couple of things like robots. Okay, I work with robots that walk and run. And here today, we're with the Integrative Movement Sciences Club, right? Where you're talking about the movement of humans and animals. So I've actually done some work with researchers on how ostriches move, okay? So what we're going to be talking about today is how we use computer programs to analyze how things move and predict how things move, okay? And a little bit of background. So we need code to program robots. So here's a fun robot from our lab. It's just a little drone, and we program it to avoid this little obstacle swinging around. So yes, we use code to write algorithms to make robots move, right? That might sound super sophisticated if you've never done it before, but the basics of how it works we will be covering today, okay? And I also work on robots that walk around on two legs. Here's an example from some of the work that we did recently, okay? But what we are specifically going to do is we're going to learn how to simulate a foul shot in basketball. That if I take a ball and I throw it at a certain speed and a certain angle, where's it going to go? Okay. And we call this projectile motion because we want to know, is it going to go through the hoop or not? And if it didn't, what do we wish we had done differently so it goes through the hoop? Okay. And we're going to code this all up in Python. It'll teach you the basics that are not just good for simulating a foul shot. They're also good for things like making a little computer game. They're good for things like controlling a robot. They're good things like for things like, making a computer program that will solve things like your homework for you. One of my favorite things to do when I was in school is I would learn to do a certain process in math or physics. And then after I do the homework, I would then do it by trying to make a computer program that does it for me to show that I understood it well enough I could teach a computer to do it. And in order to do all those things, you have to know the basics of coding in Python. Now, who here, you have to tell me because I can't quite see you. How many people here in the room have coded in Python before? And Jill or Dawn, you have to give me an essence of how many people are raising their hands. Anyone raising their hands right now? Anybody? Anyone coded in Python before? Couple up, but many, many down, I'm assuming, right? Many hands down? And that's okay. We are going to learn how to code in Python, okay? So let's go to my little magic board, okay? So what we're going to want to do today, and today is 2026. Hopefully we can see this all right, okay? The 4th of March is how I like to write my dates. I like to write them year, month, day. It's my own thing, okay? And we're going to learn to code, okay? And we're going to particularly using a computer language called Python. Now, Python's a wonderful language, especially for learning. Okay, you can get started right away, and it's very simple just to get started. But that doesn't mean that it isn't very powerful. There are people who are top of their field, like crazy, like crazy productive scientists and engineers, and all kinds of people and computer scientists who still use Python. You can start off in Python, and you can do crazy cool things in Python. Okay, a lot of machine learning and AI is coded in Python. So just because we're learning this in the basics today doesn't mean you can't use it for something very complicated. Now, it's a computer language. You might have heard of other computer languages, some examples, okay? A common one is called C or C++ or Java, all right? Those are examples of computer languages. There are lots of examples, okay? You could go on. And which language is the best to use? It depends on what you want to use it for. But I'll tell you, Python's a great one to learn, all right? And one of the advantages of Python is that you can just write a line of code and you can click run and the Python interpreter will just run it, okay? It's called an interpreted language. As opposed to something like C or C++, it's called a compiled language. It's a little bit more complicated to use at first. Still very doable, okay? But what we're going to learn today are a couple different things. We're going to learn how to print to screen, okay? And just to get everyone started, in case, so I recommend pulling up this website. If you're watching, you're going to want to go to colab.research.google.com. Okay? And this is the website we're going to be coding on. It's free. As long as you have a Google account, you can log in. Okay? No big deal. All right, it's a great way. So in order to code, you don't need any special programs. You don't need anything installed on your computer, or on your laptop, or even on your iPad, or even technically your phone. Okay, other than your ability to browse the internet. That's all you need. So it's that simple. That's how we're going to start. That's where we're going to start. Okay, we're going to start by printing to screen. Okay, that's number one. Okay, then we're going to use variables. Now, all of you are students. You've probably heard of variables, maybe from a pre-algebra class or an algebra class. It's like those kinds of variables, okay? We're going to use variables, all right? Okay. Then we're going to want to be able to plot on a graph. In Python, we're going to learn how to do that. Then we're going to do something that's really important in programming, because in programming and coding, when you want to do something over and over and over again, you put it into something called a loop, okay? We want to learn how to make a loop, all right? And at that point, we will know everything we need to be able to simulate the physics of a basketball foul shot, okay? All right? And that's all you would need, okay? That's where we're going to learn. And at any point, if people have questions, I can hear the questions in their ear as long as it's maybe repeated by Jill, who is close to the camera. Okay, so hopefully people have gotten a chance to go to colab.research.google.com. Are people, give me thumbs up, and Jill, tell me, or Jill or Dawn, tell me if people are at that website. That's where you got to go to. We're good. Awesome. Cool. Awesome. Great. Cool. Nifty. Neato. Neat. All right. So now, okay, I here am at colab.research.google.com, and hopefully people see something that looks like this. It might be a white screen or a black screen. I have the black screen setting on because it makes me look cooler, okay? And what you want to do is when you get here, you want to click New Notebook, okay? We're going to be creating a Python notebook. So I click a new notebook, and it's loading. It's creating a new notebook. Hopefully it's good. Fantastic. There we are. Okay. We have a new notebook. All right. Now, up here, I said I have a notebook called Untitled 3. And that name of my notebook is very much not awesome. I would love it to make it an awesome name. So I'm going to call it My Awesome Notebook, but you can call it whatever you want. I clicked on it, and I changed the name. It could be like Marissa's Notebook, you know? So My Awesome Notebook, okay? And this notebook gives you the ability to write code in Python, and when you just run the code by clicking the little play arrow, Google did a great job of making this very simple little interface. And I don't need these release notes. Goodbye. You can get rid of that thing on the right. That's just getting in my way. It's annoying me. Goodbye. Ah, there we are. Okay. So now if we want to write any code, Okay, all we need to do is write it into this little block right here and then click run. So we're going to start by doing the simplest thing that everyone does when you first learn a new programming language. Okay, we try to print to the screen. Okay, and what's the thing we want to print? You want the program to say, hello world. It's alive. Well, it's not alive. It prints a hello world, like welcome to the world. Okay, so hello world is one of the most famous programs you can write. And how do you do that? Well, you say, I want to print, and that's not on paper, it prints to the screen whatever is inside these parentheses. So if you say print, and you have an open and closed parenthesis, okay, whatever's inside, it will print. So if you want to say hello world, you put quotation marks, okay? And in between those quotation marks, you say hello world. And then you hit, so it should be within quotation marks, meaning you want to literally print out the word, and you hit play. And it'll take a second to run here as it's getting everything set up. Hey, look, hello world. Is anyone getting hello world? Are people able to click play and get that? Anybody? We get how we looking, Jill and or Don? Hello world. Thumbs up, thumbs up, thumbs up. Love to hear the thumbs up. Great. Cool. Now, one thing that you're going to encounter when you are coding is that sometimes you will make mistakes. It happens all the time, okay? For instance, one mistake you can make is forgetting to have the closed quote at the end. Now, you can see Google Colab is trying to warn me, like with a little spell check error saying, you've made a mistake, you've made a mistake. But let's say I try to run it, but clearly I've made a mistake, right? I hit run, and look what it says. Oh, it has an error, okay? You will encounter errors when you're coding, and then it will try to help you as to what's going wrong. But trying to fix errors is the most important part of coding. It will almost never work the first time. The only reason it might work super well this time with me is because I've done this before a lot of times, but you will run into errors. It is normal. And the sign of whether or not you're learning how to code is how well you work through those errors. That's the thing you learn the most. So errors, don't be scared, okay? It'll look scary, but don't be scared. Clearly it says, hey, unterminated string literal, or have fancy letters like that. It just means, oh, you forgot to put a quotation mark at the end, okay? So things like that will pop up from time to time. Don't be scared. Well, guess what? We can print the screen. That's step one. Check, 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 right? Now, what if we don't want to print some letters in what we call a string of letters, okay? Let's say we want to print a number. Well, we can print a number. We can just put it a number, and we don't even need it inside of quotes. We can print the number 5. It's one of my favorite numbers, probably my 5th favorite number. And I can click go, and it prints the number 5, right? Now, that's good. We can print a number. But we can also print what we call variables, okay? Now, variables are incredibly important in programming. That's what allows you to do all kinds of math and interesting stuff inside of a program, okay? So a variable is something that you name and then you can then use. So let's say I want to create a variable called X. I'm just gonna go put some, I'm just gonna put some spaces there to create another line of code above this line of code. Actually, before we do that, what I'm going to do is I'm going to print out something else. I'm going to say print, here I am, and then 5. And if I hit run, what is this going to do? It's going to run this line first and this line second. And if you had more lines, it'll be 3rd, 4th, 5th, etc. So if I run it, it'll say, here I am, 5. Okay? So this sort of procedural programming, all it means is that, hey, if I hit run, it'll run the first line first, second line second, etc. Okay? So I'm going to replace this line right here. That was just to show you how this works. I'm going to create a variable. Okay? I'm calling it X. I'm going to say that X, I want it to equal the number 1. So I'll say X equals 1. Okay? Then if I go to print, and instead of printing 5, let's say I print X. Notice that X is not in quotes. Okay, what that will mean is that it will print the value of x, which we have set to be what, friends? The number 1, the loneliest number. Okay, so if we run this, it'll run this line first, this line second. Okay, and so it ran, hey, x is equal to 1. It very quietly said, okay, thank you, x is equal to 1. And then it's going to print the value of x, which equals 1. All right, how are we doing on thumbs? Can we get some thumbs? How are we doing on thumbs here? Any thumbs? Lots of thumbs are up. Thumbs are good. Thumbs up is my favorite direction of thumb. We can also add more lines of code. What if we said x is equal to x plus 1? What this will do is it says that x is going to equal the previous value of x plus 1. So what's x going to be? It's going to start off as 1. Then it's going to say 1 plus 1, which mathematicians will tell you is 2. And so it should print 2. And there you go, right? You're doing math, okay? This is where you start to do cool stuff with coding, okay? So when you have this equal sign, that equal sign assigns variables. And one thing I want to do also, so these are lines of code, right? Well, let's say, my friends, you're looking at a whole bunch of lines of code and you just want to say, I want to add a comment to this. It's not actual code. It's just something for me as a person to read, to know what this is. Commenting your code is very important. How do you do that? Well, in Python, you can put some spaces and you can say hashtag or pound, okay? This is a comment. So everything here after that little pound sign, the hashtag, the code doesn't care about. That's just so we can read it, okay? That's for documenting the code. We just like, this is for what we call documenting the code, all right? And that's helpful. Why? You could do all kinds of important things in your code. So I can go up to the top of my code, add some new lines, and I can do things like put my name on my paper. We still put our names on our papers in school, right? That's still a thing that is done, right? I would assume. So I could say, hey, this is the title of this. This is like my awesome notebook, right? And I can make another line and it says Christian Hubicki, my name, right? Say by Christian Hubicki, like you might put on a paper, right? And we're working together on this. So I could say, and friends, all right? You're all my friends. We're all friends here, right? Thumbs up for friends. We're friends. Good to see you. Okay. The fancy Latin way you sort of say and friends or with colleagues is you say et al. So, et al, like we're with buddies here. Okay. Christian Hubicki et al. All my friends here. Right. And you can put the date, which I, of course, love to do 2026, 03, 04, right? Those are comments. The code doesn't read them. But that's so we as people can read them. We good on that? Any questions on it? Any thumbs? How are we doing on thumbs? Thumb check. Thumb check. Thumbs are up. Great. Awesome. Cool. So we've done 2 of these things. We have now created variables. Now you can create a variable that has any name, okay? Ooh, I just tried to dip this in my coffee. That's not how this works, friends. Don't do that. Okay. So you can name a variable anything you want. It could have multiple letters. You could call a variable called variable, and we'll say it's equal to 50, all right? And then I could say, I want to print variable, and it'll print the first variable, then the second variable, right? It prints my variable 50. The only thing you can't do is put a space in a variable name. And you also can't start with a number. So as long as it starts with a letter and there's no spaces, so if I try to do bull, it'll yell at me. It's not going to work, okay? It doesn't like it. You can't have a space. That's the only rule. That's one of the only rules with naming variables. So you can make it a name that you recognize, right? Okay, so we can work with variables. Question. Was that a question? No question. No questions. All right. Okay. Now, next thing, my friends, we are now going to go back to our screen. we are going to want to plot on a graph. We all know about graphs, right? We've experienced graphs in our schooling, but it's great when you can have a computer program make a graph for us, okay? So we're talking a graph. You might have seen a graph before where you have an x-axis and a y-axis, right? And let's say you wanted to graph a point, okay? It would, that point would have coordinates. You want to say, hey, this is the x point, and this is the the y point, right? So you can plot a point on a graph or multiple points on graphs, all right? So let's start with just plotting a single point on a graph. Now, if we want to start plotting on graphs, we have to go back to our code, all right? Okay, all right. So we're back to our code. We want to plot on graphs, excuse me, put that back there. What we need to do is tell Python, hey, in this piece of code, we want to plot with graphs, all right? And so what we need to do is include something called a library. And let me see if I can make this big enough here. So we need to, for plotting, to plot in Python, let's go back here, apologies. So for plotting in Python, you can use a library called matplotlib. So it's a matrix plotting library. Okay, that's what it stands for. But we have to tell Python we want to use matplotlib, and then we will be able to create some graphs and plots. So let's do that. Let's go back to my screen. So we have to tell Python we want to use matplotlib, which means we have to import the library. This is where things you have to start memorizing a few things or writing things down. So the way you do this is you say, I want to import matplotlib. I'm putting it up at the top because it's the first thing I want to do. Matplotlib, I want to import it. And you say dot pyplot. Let me make this a little bigger so you can see. Dot pyplot, Pyplot, matplotlib.pyplotpt. That's Python plot, okay? And to see if this works, let's run the code, and it should work. I don't see any errors. That's good, okay? So it works when you run. So now whenever you run the code, it now imports the ability to plot, okay? So what you could do is I'm going to go to the end here, and I'm going to write matplotlib.pyplot.plot. Okay? This is going to create our ability to make a plot. Okay? And what you need to be able to give it first are the x coordinates. Okay? So let's say we want to plot the point. Where are we here? We want to plot the point where this is the number 3 and this is the number 2. So 3, 2. If you wanted to plot that point, you would say 3, 2 for plotting a single point, right? All right. And then when you are done plotting, we have to tell the plot you want to tell the code you want to show the plot. So you would say matplotlib.pyplot.show. And you have to put it. So by the way, you'll notice I had to put it inside of those parentheses. That's how you tell it. Inside the parentheses, I want the coordinate 3, the coordinate 2. And then I want to show it. So then you have to include just an open and close parenthesis. The reason you have the open and close parenthesis is this is what tells it's what tells Python that this is what we call a function. If you're in high school, you probably learned about functions. All it means is that you have to give it inputs, and inside of the parentheses are your inputs. It doesn't need any inputs, so you just give it open, close parenthesis. Let's try running it and see what happens, friends. I ran it, and sure enough, where's my plot? Where's my point? Can I see it? I can barely see it. Somewhere there. I think I gotta make it a little black X. Let's try this. There we go. Okay, so you got to tell it the coordinate, and then you have to tell it what it looks like, okay? So I'm going to, let's say I want it to be a little X. So I have to do a little apostrophe X apostrophe, and it'll draw a little X marker where I want it to be. So if I run that, it makes it a little blue X. Do you see that? Let me zoom out a little bit. Anyone getting this? Am I getting any thumbs? If I do a comma, X, it adds a little X. Any thumbs, or we need any questions? Fantastic. Great. You see the blue X? Yep. And guess what? Look where that X is. 3, 2, right? Awesome. Now, if you want to change the color of that X, there are different color codes. Right now, that is a blue X. If you wanted to make a red X, you could change this piece of code here. Instead of saying X, you say RX. It says, I want a red X. I can rerun it, and guess what? It's a red X. What if I want an O, or like a point, like a round point? The code for that is we change the X to a little lowercase letter O. Now run it again. Look, it's a dot. Great. Everyone getting this? Thumbs up, thumbs up, thumbs up. All red dots. Great. Okay, awesome. All right. Now, that's cool, but isn't it a little silly we always have to type out the entire matplotlib.pyplot.plot, matplotlib.pyplot.show? And if I wanted to plot anything else, let's say I wanted a different point, I'm just going to copy this line here. Just copy, copy, copy. I'm copying that line. I do matplotlib.pyplot.plot. And let's say I want another point. I want a point at 4, 4. And I want it to be a blue X, so BX. So 4, 4, blue X. This should plot both of these and then show the plot. Okay, I'll keep that up. And sure enough, if I zoom out, you can see, hey, there's a circle there, there's an X there. Let me know if I'm starting to get thumbs. Once I start getting thumbs, I'll move forward. Any thumbs, any thumbs. Just copy and paste, change it to 4, 4, BX. Anyone get both? Oh, getting thumbs, getting thumbs, getting thumbs, thumbs, thumbs. Okay. All right. So now, but isn't it silly you have to write matplotlib.pyplot.plot, matplotlib.pyplot.show? It's so silly. Let's save your fingers some effort. So the way we do this is we go back to our import and say, hey, we don't want to always call it matplotlib.pyplot, whatever. We just want to say plt, plot, plut. So we say as PLT. This is called an alias. And if you know what an alias means, it means you give it like a fake name, right? So now, if we say this and we run it, instead of saying matplotlib.pyplot.plot, we can replace all of this matplotlib.pyplot with just PLT. Much easier, right? Same thing with anywhere we see it. We say PLT. PLT. So now it's just PLT.plot, PLT.plot, PLT.show. And if you did that correctly, you should be able to rerun it and it works just fine. Okay? Works just fine. Okay? Let anyone, and so it should look exactly the same. Now it's just PLT. Anyone getting thumbs? Am I getting any thumbs up? Any thumbs up on that? Thumbs up? Half thumbs up? Say as PLT, PLT.plot, PLT.plot, PLT.show. All right? And mentors can go filter through the audience and help out there as well. Okay. Good. All right. So now, my friends, you might be saying, what if I want to do multiple points? And you'd say, do I have to do all these different plots over and over again? That gets exhausting. I agree with you. What we need is a way to plot lots of points, a list of points, if you will. Okay? So in programming, what we want to be able to create lists of numbers. Okay? That way we could have multiple points. So imagine we wanted to create a plot where it looked like this. Like we're going to draw the letter Z. Okay? How would we do that? Well, what we would do is we would find all of the X coordinates in order for which we want to draw it. Okay? So let's just say that this is, that's 1, that's 2, that's 1, that's 2. This point up here is going to be 1, 2. This is going to be 2, 2. This point's going to be 1, comma 1. This point's going to be 2, comma 1, right? So if we can give, instead of a single point to our plotting, we can give a list of points. We can give a list of x points that looks like, I'm just going to draw this list in a square bracket, which has our first x point 1, then 2, then 1, then 2. So, right? So I could say 1, comma 2, comma 1, comma 2. Right? And my y points would be 2, 2, 1, 1, 2, 2, 1, 1 in the order that I want them drawn, I want this line drawn. Okay? So I could say 2, 2, 1, 1. All right? Okay. So how do we do that? So all right. So we're going to go back. So all we need to do is create a list of numbers. Okay. Now, to create a smart list of numbers, we're going to need another library like we did with PyPlot, with matplotlib plyplot. And this one's going to be called numpy, N-U-M-P-Y. And it's good for making lists, smart lists of numbers. In fact, you can make lists that are not just a row. You can make lists that are like a row and a column. So you have like a block of numbers. Does anyone know what that's called when you have a block of numbers? Does anyone know the answer to that? Let me know if anyone in the audience knows what happens when you have rows and columns of numbers. Anyone know? There's an old movie with the same name. It rhymes with Matrix. Yeah, vectors. Yeah, but the Matrix. Okay, but also vectors. Okay. Yep. So that's what the matrix for the plotting. Anyway, you can do all kinds of cool matrix math when you need to have numpy. So we're going to have to go back to our code. We need to add to our import. We need to also import numpy. Okay, so we're going to say import numpy. Okay, and we're not going to want to write numpy many times. We're going to make it shorter. So we're going to create an alias. We're going to say as np. Okay, so if we want to make a list of numbers, so what we're going to do actually is we're going to delete these 3 plots. Are we okay with that, friends? We'll miss them. We're going to send them away. We're going to delete these 3 lines. Gone. Okay? Because what I want to do instead is plot this little z here. Okay? So in order to do that, I'm going to create a list of x coordinates, and it's called, specifically, it's called an array. A-R-R-A-Y. That's like a fancy word for a list in programming. Okay? So we would say that x is equal to np, meaning we want to use the numpy package to create an array. A-R-R-A-Y. Open parenthesis, close parenthesis. Now we want to create a list of numbers. So we want to use a square bracket. So a left square bracket and a right square bracket. You'll notice that it automatically gives you the right half once you click the left half, right? Okay. So now we're going to say, all right, so we want our x coordinate. What is it? It is this, friends. It is 1, 2, 1, 2. So let's write that. 1, 2, 1, 2. And if you want to make sure you did it right, you could always print x to make sure that it's working. So I'm going to create a new line. I'm going to say print, open parenthesis, x, and it should print what the array looks like. So when we do that, let's run the code. When I run the code, this is what I see. I have this old 2 and 50. Oh, I feel like we got to get rid of that too. Goodbye, friends. We're going to get rid of that. I'm going to get rid of it. Goodbye. We miss you. We don't need it anymore. We already know how to print things. Okay? All right, we're going to run it. Now, if I run it again, it just creates this numpy array, and then it prints out the numpy array. 1, 2, 1, 2. You got to make sure you separate it with commas, and that's it. Anyone getting this? Anyone getting this? Am I seeing any thumbs in the audience on this? Thumbs up, thumbs up. Great, we have our x coordinates. What do we need now? Our y coordinates, okay? Our y coordinates, So we're going to say y is equal to np.array. We're going to make an array. It's going to have those 4 points. 2, 2, 1, 1. All right? Okay, let's print y to make sure that's all working out okay. So I change that to print y, and then I run my code, and when I see 2211 pops out, this is the value of using prints to make sure that things are working right, okay? Am I getting any thumbs? Any thumbs on that? Thumbs? Thumbs up. Thumbs? Thumbs up? Great. So almost all thumbs. We'll keep going, all right? So now we have x and y. Now let's plot x and y. So in order to do that, we're going to say plt dot plot, open parenthesis, we want to give it our x coordinates. We have a list of them called x, and a list of y coordinates called y. So x comma y, okay? And I want them to be a line. So I do open, I do a single quote, a little apostrophe, gives me 2 single quotes, and in between I'm going to do a hyphen for a dash that tells me I want to connect them with a line, all right? Let me run it. When I run it, what do I see? I see a Z. Let me know give me thumbs when you see a Z. Give me thumbs when you see a Z. plt.plot x comma y comma hyphen. Do you see a Z? Any thumbs for a Z? See thumbs for all Z's. We did it. We plotted a Z. And why is that going to be important, my friends? That's going to be important because we're going to want, this is where we get to close to the physics of what we need, where we're going to want, I'm just going to draw a little temporary thing. We're going to draw some axes, and we're going to say, hey, our basketball shot's going to start here. Where does it go? Where does it land? Does it land in the hoop or not? We're going to want to plot all that stuff. Guess what? We know how to plot. So when we have this little curve like this, instead of just drawing a couple of points like a Z, we're going to have a ton of little points to plot that curvy line. Okay? So all we have to do is get the plots for that, all the points for that curvy line, and we will know where the basketball is going to go. And for that, we're going to use the physics. Okay? But we're all getting the Z, and I'm glad to see it. So, all right, but we're close. So we're close here. All right, so now finally, we are going to start getting close to the physics. So what we will need to do is I'm going to write this in comments, is we need a list of points or arrays for the x and y coordinates of the basketball over time. Okay? All right. So how do we do that? Because we're talking about getting a lot of points, right? You can have 1,000 points to give you the time. So if I had like 1,000 points that along the course of that little arc, right? And I plotted them with that little line command, it'll look like a nice curved line. Now, my friends, who here, give me a thumbs up if you want to type out 1,000 numbers with your fingers. Any thumbs up? Any thumbs up? Am I seeing any thumbs up when people want to type out 1,000 numbers themselves? Anybody? No thumbs up. No thumbs down. Thumbs down. We don't want to do that, right? So now we get to use, so we're going to have the program help us by automatically making that list. And we're going to do 2 things. The first thing is we're going to create just a list of numbers automatically. So let's say we wanted to start with a number, the number 0, and we wanted to end at the number 10, but in between, we wanted 1,000 points, okay? So like, for instance, if we wanted to simulate what the ball looked like at time equals 0 seconds, and then 1,000 points in between when the time at 10 seconds, then we could have Python automatically make that list. How would we do that? Let's create a variable. We'll call it time. And we're going to use the numpy library, so np, and we want to create a linear spacing of points in between 0 and 10. So we're going to say np.linspace, open parenthesis, 0, comma, 10. So where you want to start at time 0, end at time 10, okay? And then let's say we want 100 points in between. Say comma 100, okay? This will make a list of points between 0 and 10, and it makes 100 of them, okay? How do I know? Well, let me print out time just to check, okay? So I'm going to do that. I'm going to print out time, and sure enough, look at that. Print out time. Look at the list. 0, 0.1, 0.2, all the way up to 10. Anyone getting this? Am I getting any thumbs on this? Is able to print out this list here? Okay? Any thumbs? np.linspace, great. So doesn't that save us time? That sure is nice. That sure is nice. So at any point, so these are many points in time we may want to plot, okay? But what we need are the X and Y coordinates, okay? All right? So at every point in time, we're going to want to say, at that point in time, the ball is here. At the next point in time, the ball is there. And then across all those points, we'll plot it and we'll get the arc, okay? So for that, we're going to use a little bit of physics. So let's go back to the board, okay? So this type of physics is called projectile motion. Meaning that it's an object that its only force on it is gravity, okay? Meaning that the ball is in the air and there isn't a bird that's crashing into it. There's not a rocket thrusting it and moving it around. It's just in the air, okay? And we will assume there's no air resistance that's slowing it down, okay? So it's a projectile motion. So if you have a ball or any object, it will have a speed or a velocity in a certain direction. So a velocity in the X direction and the Y direction. If Vx is 0 and Vy is positive, the ball is going straight up. If Vx is positive and this is 0, then the ball is going to the right, all right? If you have a combination of positive and positive, the ball is going diagonally in some direction, okay? The bigger this amount, the more horizontal. The bigger this amount, the more vertical. Does that make sense? Okay? So if you have some velocity X and velocity Y, when you release the ball, okay, where's it going to go? Given the fact that you also have gravity, okay, often called G, and it has units. In metric units or international standard units, it's 9.8 roughly meters per second squared, okay? What that means is that every second, the velocity decreases by 9.8 meters per second, okay? That's what that means. That's the acceleration. This is called the acceleration due to gravity. So the acceleration. Now, we don't have a ton of time to get into how all that works, but there are some very straightforward equations I'm going to write down that'll tell you how to compute where the ball is at a certain period of time. So here's the equation. So X, question? Okay. So X is equal to X0, that is the initial point at X where you are standing. So if you're standing on a graph, this is where you're standing, okay? What's your X coordinate, okay? Plus Vx0, that's this right here. It's just at time 0, meaning when you release the ball, what is the X velocity or speed, okay, that you release it, times time, t. That's time, okay? And this kind of makes sense. If you are driving on the road and you start at your house, that's your X coordinate, and you move, and you're moving at just say a constant velocity, 60 miles an hour, right? Well, how far did you go? Well, this is where you started in miles, let's say. It can be meters or miles or whatever. Plus your speed times how long you've been going at that speed, right? This is miles per hour times hours. This becomes miles, and that becomes miles, right? Very simple math there, okay? It only gets a little bit more complicated when you deal with y, because gravity is changing your speed all the time. It's in the air. The ball's going to start falling back down. It's accelerating back toward the earth, okay? And it's y is equal to y0, which is your initial vertical position where you're releasing the ball, plus vy0 times t, okay, minus 1/2 gt squared. Okay, so if you plug in your y, your velocity, and your current time and gravity, it'll tell you where you are. Okay, so all we need to do is get our initial x, vx, y, and vy, and then ask ourselves, what time is it? Over and over and over and over again. Time 0, time 0.1, time 0.2, time 0.3, and it keeps giving us more x's and y's, okay? So to do that, we're going to put it in what we call a loop, okay? So we need to create a loop in Python. So let's go back to the code, all right? So we need to create a loop, and let's get rid of the print time. We no longer need it. We now know the time works, okay? All right, so we're going to create a loop. So create a loop. All right, and we're going to create something called a for loop. All right, so one thing we want to do first, okay, is we're going to create an array of empty values for x and y, okay? So, for instance, if we want 100 points, okay, what we can say is that, hey, I want x to be an array, let's just say it's full of zeros, okay? There's an easy way to say that. We just say np zeros, let's just say 100 of them, okay? 100 zeros, all right? I'm going to print to make sure it's working. Print x. Hey, 100 zeros. Works fine, right? Okay. All right. By the way, we're not our z. Are we ready to get rid of our z? We loved the z. The z's going away. Goodbye, z. We don't need it anymore. We're making our code very short here. All right. Then we're going to create y is equal to np.zeros 100. Okay. This is going to create an array of 100 zeros. Okay. And then what we're going to do is we're going to individually change that list. So instead of being 0, we're going to say, hey, we're going to use this equation at time 0 to update that this first number in the list. We call the first element, okay? Then we go to the second number, then the third number, then the fourth number, okay? And we're going to update them all. I'm going to do that in a loop. So the way we do the loop is we say for, that's called a for loop, which just means for every one of these things, we want to do a loop for it. It's just a little bit of an arcane phrase. It's a loop. We want to say for, and we create a variable we're going to call I, and it's going to be in range, okay, open parenthesis, 0, 100, okay? What this does is creates a list, an array, from 0 to 99, which is 100 different numbers. Okay, so in the first loop, it's going to say, hey, I, it's equal to 0. And then when it's done with the loop, it'll come back to the top and then say, hey, I is the next number, which is 1. Then I is the next number, which is 2, all the way up to 99. All right, we're almost done here. And we need a colon, not a semicolon, a colon right there. Okay, all right, colon. Then when you hit enter, you'll notice that there's a little indent right there. That's important. Keep that indent because that tells you if it's inside the loop or not. Will it be looped or will it not be looped? It'll just go back to the beginning over and over again. So what we're going to do is we're going to say, hey, x, we want to change the first element of x. So we'll call it, so if it were 0, if the very first element is the 0th element, okay, that will be this right here, okay? If we wanted to change what the 10th element was, it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be 9. So for instance, if we changed this to x9 equals 1, this would assign the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 value equal to 1. In fact, I'll show you what that looks like real quick. So if I print x, if I ran it, look, I changed the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 value to 1. Okay? I assigned it to be 1. I can change individually those elements of the array. So instead of doing the 9th value, I want to choose the value of the current number in the loop. So it'll loop from 0 to 99. So it'll change this number, then this number, then this number, then this number with the current equation. So we're going to say xi is equal to x0, which we didn't define yet. Oops, we'll have to add that in that definition later. You can see it's warning us. Oh my goodness, you didn't define x0. That's okay. We'll define it in a second. Is it plus bx0? Again, it's like, oh my goodness, you didn't define x yet. Oh no. Times t. Oh no, we didn't define t yet. We didn't define t. It's okay. It's okay. It's all right, friends. All right. We'll add that back in. So we're going to have to define, before we do the loop, we're going to have to define where we throw our ball, where we're throwing our ball from, and the speed. So and then we'll do y, open bracket I. So this will change the ith value of the list. It's equal to y0 plus vy0. This is just the equation I have in here, okay? Times t. So times is by the way, the asterisk key is times, okay? Minus 1/2, so 0.5, times g, which we also didn't define. So it's yelling at us. You didn't define it. It'll give me an error. Times t, which we didn't define, squared. So if you want to take something to the second power, the symbol for exponent is double asterisk 2. Okay? That's how we write these. This is how we write that equation right here. Okay? Everyone following along? We haven't run the code yet, okay? Because we're missing a couple things. We have to define x0, okay? So we're going to say define our variables. We're going to say that x0 is just equal to 0, okay? This is our initial position of where we're standing, okay? y0 is the height we're going to release it from in meters, okay? Let's just say we're releasing from 2 meters in the air. 2. Okay? Now we need vx0. This is the speed in the x direction that we are launching the ball with, okay? vx0. Let's just say it's 5, okay? Positive 5. And then vy0, let's also say it's 5, okay? And we can tell the units, we could say comment, this is in meters per second. We could comment and say, hey, friends, it's meters per second. So that way, when we're reading our code or anyone else is reading our code, we could say, hey, these positions are in meters. This is in meters per second, okay? And finally, we need g, okay? And g is 9.8, okay? And that's in meters per second squared, okay? The only thing we haven't defined is t, and the time is going to update with every element of the loop. It's going to start time equals 0, time equals 0.1, time equals 0.2, etc. So the way we say this is we create a new line, and we say t is equal to time, which is our vector of all those time points up here, and we want the ith value in the list. So if you're on the first value, if you're on the first loop, it'll give you the first element. Second loop, it'll give you the second element. This is called indexing, when you try to grab a particular element of a list, okay? Now I'm going to run it and see what happens. And sure enough, my friends, I'm printing off x, and you can see x is getting bigger, okay? Let me know if you're getting any thumbs on this. Am I getting any thumbs? I'll leave the code up here. This should be all the code you need. Any thumbs? Any thumbs? Okay. I'm getting there. We're getting there. Okay. We're okay on time? What? What's that? We're okay. Okay. We don't have to rush. Okay, well, we're almost done. We're almost done. Okay, so that's great. We print X and it looks like this. Hey, look at this number. It's continuing to go up. That makes sense. We have a positive velocity. It's going to the right over time. Now, if we print Y and rerun it again, we can see what happens to the ball. Let's run it here. You can see, ignore the little E2s, right? But it's basically, it's 2, 2.5, 2.8, blah, 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 blah. It's going up, and then, oops, it's going down. It's going down. It's becoming negative. It's going through the floor. Okay? Let's plot it, my friends. Let's plot it. Let's plot the trajectory of our ball. So we're going to plot the trajectory of our ball. I got rid of the print. We don't need the print no more. It told us that things are working okay, it seems. But let's look at what happens. So how do we plot? Well, we say PLT dot plot, open parenthesis, our X coordinates. What are our X coordinates? X. What are our Y coordinates? The variable Y. And let's make it a line. So, comma, open, comma, single quote, and a dash. Let's see what happens. I'm going to run it. Look at that. Look at this parabolic arc, okay? You can see what happens. It goes up a little bit, and then it crashes through the floor. Oh, my goodness. Crashing through the floor. All right? All right, sounds good. So we've got that. So we as a result, so I think what's happening is that we're simulating this basketball shot for 10 whole seconds. Who here has thrown a basketball in their lives? Anybody? Can anyone give me a thumbs up if they've thrown a basketball in their lives? Anyone saying thumbs up? Has it been in the air for 10 seconds? Anybody? Probably not. If your thumbs are up, I'm very impressed by your strength. Okay, so what we're going to do is we're going to change it. Instead of being up when we're defining our time vector, our time array, we're not going to go for 10 seconds. Let's go for 2 seconds. 2 seconds. Okay, so I'm change that from 10 to 2. I'm going to rerun my code. Okay. All right. Oh, look at that arc. Look at the arc. Okay. Hey, look, it's the arc of a basketball. Is anyone seeing that? I'm getting a thumbs up on seeing the arc of that basketball. Yep. Yep. So we got thumbs up. That's wonderful. Okay. So now here's the question. Did it go through the hoop? Did it go through the hoop? Well, let's plot where the hoop is. So let me pull up my, all right, simulating a foul shot. All right, and I'm seeing comments on the YouTube channel. I apologize if you're not seeing that. And I'll tell you what, for those who are watching on YouTube, real quick, I'm going to put a link. Let me share so that way you can follow along, with the code at the end. Let me see if I can share this link. I'm going to put this share link in the YouTube. So copy link. Anyone with the link can view. Okay. So if you go into the YouTube channel, I can see your thumbs up and seeing thumbs up in the chat. But in case you can't, I think that this link here should work. Let's make sure that everyone has access to this link. Okay. I believe it works. Yes, it does. So it's in the chat, and I'll put it in the notes after the show. So I do see it. I just can't see all the comments. Okay. So, all right. So let's find out where the hoop is and plot that as well. Oh, we forgot to say, you know what I forgot? PLT.show. It worked anyway, kind of, but it sort of gave me a bit of an error. So PLT.show. Here we go. We're showing the plot. Look at that. Whoo! PLT.show. Let's plot where the hoop is with make a little circle where the loop is, okay? So where is the loop, okay? A loop, so a basketball hoop, okay, is going to be at the foul line about 15 feet away for a high school basketball court. What's that in meters? That's about 5 meters away. And up in the air, how high is it in the air? Roughly what? 8-10 feet, so 3 meters in the air. So it's 5 meters over, 3 meters up. So let's draw a little circle, 5 meters over, 3 meters up. So let's say plt.plot, okay? And we're just going to make it 5 meters over in X and 3 meters up, and we'll make a little red circle. So ed R0, okay? And we're going to compare where the shot goes versus the circle. All right, everybody ready? I'm going to run this again. Hey, look. We have the arc. Does it go through the hoop? No. Is anyone seeing what I'm seeing, though? Am I getting any thumbs? You got it. We're pausing, and I'm looking at the YouTube comments. Okay, for those who have thumbs down, I apologize. So you can go through the cool. Yes, this is projectile motion. We're just doing simple projectile motion as an example of things we can code. Okay, I can show more of the code if people need to see it. I can also, yeah. Here we go. This is all the relevant code that you need. Yes, I hear you. Okay, the problem is I'm trying to see the picture of the classroom here. Okay. Let's see. Give me a second. I'm going to stop sharing my screen for a moment so I can see what you all are seeing, okay? I don't know why I can't. Oh, there you are. I see where everything is now. Okay. Oh, does that look like a fancy curve? Very. I think I know what's happening. Question, friend. I imagine this is all inside of the loop. Did you get rid of, so you do not want to plot the changing trajectory every element of the loop. So how do you make sure that this is not in the loop? So you can't see. Let me make sure you can share. Okay. One second, friends. I'll make sure you can see. So you take it out of the loop is what you got to do. I'm going to make sure I can share with you guys again. All right. Okay. Yeah. There you go. I see what's going on here. All right. Okay. Hope we can see that again. We're getting thumbs up. That's great. That's great. Thank you so much. Okay. All right. That's those people on Zoom right now. So by the way, people on YouTube, I'm talking to the live classroom people in Zoom while also looking for you. So thanks for your patience while I'm looking at what you're going for. Okay. What a time we live in. Okay. So now people are seeing this, right? You're seeing a single line and you're seeing the little point there, right? Okay. You should have so the key is that if this is not inside the loop, you don't want this looped. You have to make sure there's no indent right there. Okay. So once you get rid of the indent, you're out of the loop. Okay. Any other questions? Okay. A two lines showing up. Well, I'll tell you, if you could, let's see, you could pull, I'm making sure I can see, I wish I could see everything a little more easily with where the thing, I can unshare my screen if you want to show me the code again. But like think ideas. Okay. So the only things you should be able to plotting, you want to show the thing again? Okay. Sounds good. So, yep. And if you want to go check the code directly, you can go into the live chat, and let me give you the exact link to my, I'll throw it into the chat in Zoom so that you can compare the, okay, hopefully this works. You can try that link and hopefully you can see it in the Zoom chat. Okay. So for those who are getting this, is anyone getting what I'm seeing, or is everyone getting multiple lines? Okay. So if you're getting what I'm seeing, okay. All right. Let's have a fun task. How do you change the speed of the ball in our code? Well, you want to change these two values, Vx0, Vy0. Those are the initial speeds of the X and Y. I challenge you to change those speeds so you get a correct foul shot. Can we do that, friends? Let's have a little challenge, interactive challenge, all right? And we'll have an informal race to see who gets there first, who can get there through the ball, okay? Everyone, people are ready? I'm going to start changing it too, and we're going to race, all right? Friendly race. I'm going to change it's a little too low, so I'm going to make my vertical velocity higher. I'm going to make it 6 and see how it works. Okay. Oh, whoa. Okay, that's too good. I got to make it, so I'm going to have to make this go through the center of the ball. Okay, I'm going to make it go a little slower in the X direction. I'm going to make it 4.8, 4.8, 4.8. Oh, a little too slow. I want it to go through the center of the ball. I'm going to do 4.9, 4.9. Oh my god. Yeah, the red hot. We're trying to, I think I hit the red dot. Okay. That's a way to hit the red dot. But this is a bit of a shallow foul shot. Okay. And Dawn and Jill have given me some materials that you all have worked through showing that, hey, if you have a lower angle, that's bad for a foul shot, right? Let's try to hit a much higher angle. Okay. So let's try to shoot it up higher so it comes down at a steeper angle. Let's try to find a speed that does that. So I'm going to help do that as well. Okay, so I'm going to increase my Vy, my vertical velocity, by a lot. I'm going to make it 10. So we're going to try to shoot high. Okay, I'm going to see what happens. I'm going to shoot high, and sure enough, whoa, I'm way overshooting, right? Way overshooting. Okay, 4.9 and 10. So, but I'm going to try to slow down my horizontal velocity so it comes down through the hoop from a super high angle. Okay, so I'm going to change it to about 2.5, the Vx0, the horizontal velocity. Okay, yeah, and in the YouTube chat, you can change oh yes, yeah. So in the YouTube chat, people were asking why doesn't Vx change over the course of the throw. That's because Newton's laws say that that any object in motion remains in motion unless acted upon by a force, and horizontally, without air drag, there is no force. So it's moving at a constant speed that way, but changing speed vertically because there's a vertical gravity force. Okay, so hey, look, I'm a lot closer with my 2.5. So I'm going to shoot a little faster in the horizontal direction, so 2.7. Okay, 2.7, a little too much, I'm going to go down to 2.6. Is anyone playing around? I get any thumbs of people able to play around with these speeds and see what happens? Anybody? Thumbs up in the chat. I'm gonna try 2.55 and see. Look at that. Oh, a little too slow. Let's try 2.57. I'm getting really tight on these numbers, right? Oh, 2.57, I meant to say. 2.57. All right. All right. A little too slow. 2.59. 2.58. Oh my goodness. Look how precise I have to be when my ball is going so fast, right? So one thing you're going to notice is that the faster I'm throwing this ball, even if I'm throwing it high, I might have to be more precise in order to go through that hoop, right? So there's a balance that you don't want it to be too shallow and slow, and you don't want it to be too high and fast, because if you're off just by a little bit in your speed, you lose. You don't get the shot, okay? And when you are looking at your data from the Integrative Movement Sciences Club, when you're looking at data of video of you shooting a shot, right? Okay? You can take those velocities that you measure, put them in this code, and see where they should end up and see if they end up in the basket. And if they don't, you can figure out how to change it so it does. And with that, that's the end of what we need to cover. You now have a simulation of projectile motion. So I'm happy to stick around for any questions from the class. Thank you very much. That's That's awesome. Fantastic. And just to repeat that for people who don't access to the audio, for those in YouTube, I'm on a Zoom call and I'm getting the private audio from this classroom here in the United States of middle school and high school students. And what they are doing is they actually went out to a basketball court, took video, and analyzed their launch velocities, and they are currently putting that data into their simulation to see what is actually happening to the shot that they shot. So that's awesome. On the YouTube comments, I'm seeing hello from India. Fantastic. Hello from the United States. All right. Anything else I can help people with today? Happy to stick around for a bit to help people debug. All right. Cool. All right. Sounds like on the YouTube stream, we're finishing up for today. Thank you for everyone who stopped by on the YouTube stream. It's great. If you at any point, you can back this up and you're all good. Thanks for coming.